You almost forgot, didn't you?
What?
All right.
Hey, step 2 here.
So, charge of ions. All right, so you should probably take out that periodic table I gave you while we do this lesson, so that as I'm giving you the charge for each group, you can write above that group, above each column, what the charge is for those elements. All right. All right, so before I give you the rules, let me kind of explain how this works, because all this charge stuff is based on valence electrons. So it's really kind of simple. So let's think about a small atom like lithium. You can write this off to the side, and then I'll come back and give you the rules. So let's think about a lithium atom. Okay, so lithium atom has 3 protons, 4 neutrons, and has 3 electrons. 1 electron is in the outermost shell here. So when lithium atom ionizes, it's going to lose that electron. It's going to be taken away by probably some non-metal, right? Fluorine, chlorine, oxygen, something like that. And when it goes away, lithium now has 3 protons and 2 electrons, which means it has more pluses than minuses, right? Which means it's going to have a positive 1 charge. So when it loses an electron, it has a +1 charge. This is why last chapter on that test, I was telling you, don't write loses 1 and then put -1, because it's going to confuse you. When something loses an electron, it has a +1 charge. And then, of course, it's the opposite for the ones that gain electrons. They have negative charges, because they're going to have more electrons than protons. All right, so keeping that in mind, here we go. So, let's do pluses. Atoms with 1, 2, or 3. Erase this. 1, 2, or 3 valence electrons will lose all valence electrons. So what that should mean to you is, if something has 2 valence electrons, it's going to end up with a +2 charge, because it's going to lose 2 electrons. If something has 3 valence electrons, it's going to lose 3, it's going to have a +3 charge. Okay, so this makes it pretty easy. That means group 1, and everybody make sure you know where group 1 is, because after I explain this, I still have people confused. It's the first column on the periodic table: hydrogen, lithium, sodium, potassium, right? Group 1 have a +1 charge. That's this first column.
Wait, how do you know that they have a +1 charge?
They all have 1 valence electron, so any one of those, when it reacts with something, is going to lose that 1 electron.
Okay.
+1. Actually, if you guys look up there, I wrote above each of the columns what the charges are. Okay, group 2, and you should write this above group 1 on your periodic table, write +1 so you know all the ones that column +1. Group 2 have a +2 charge. And group 2 is beryllium, magnesium, calcium, strontium, barium, right? Second column. And again, you know they all have 2 valence electrons, so they're all going to have a +2 charge. And group 3 have a +3 charge. Okay, now, and I'll insert this picture into the video later, but if you look at the periodic table, okay, you got groups 1 and 2, and then just forget all this middle stuff, right? All the transition metals, the orange ones and the ones at the bottom, we're just going to assume those are all +2 charges. We kind of ignore those. There's these 2 groups and these 6. Those are the ones that we really care about. Okay, so I just talked about 1 and 2. Now we skip over to group 3A, that's boron, aluminum, gallium, and do from there over. Okay, so I did group 3. Group 4 is kind of weird. It's So I'm going to skip group 4. I'm going to leave it for the end. I'm going to do 5, 6, and 7. Okay, groups 5, 6, and 7. So, and I'll come back to group 4, which is the carbon group, and explain in a minute why. All right, so atoms with 5, 6, 4, 7 valence electrons. And I told you guys this a long time ago, right? If they have a small number, it's easy to lose the electrons, and then the next lower shell is the full outer shell with 8 electrons. If they have a number that's close to 8, 5, 6, or 7 is closer to 8 than it is to 0, then they just gain a few. That's the easier thing to do. So these gain electrons until they have 8.
Are we supposed to leave the space for like group 4?
No, I'll do group 4 at the end. Don't worry about it. These are the ones that are more constant, and so that's why I do them first, because the rules are consistent with those.
When you say 8, you mean like in the outer shell?
8 in the outer shell, yeah. So they have 5, 6, 7 valence electrons. They're going to keep gaining until they get to 8 valence electrons. So this tells you the group 5 has to gain 3, right? Which means the charge of group 5 is going to be what? Group 5A, 5A, yeah, minus 3 charge. 5 plus 3 is 8. So they gain 3 electrons, which means their charge is minus 3. So the group 5A is the nitrogen group. Nitrogen, phosphorus, arsenic, antimony, so on. Group 6A, what are these going to do? Minus 2. All right, they're going to lose 2 electrons. They're going to have minus 2 charge. Sorry, I just said that wrong. They're going to gain 2 electrons and a minus 2 charge. And this is the oxygen group. Oxygen, sulfur, and whatever's below that. And then group 7, 7A, or 7B on some periodic tables, be minus 1 charge. These all have 7, so they gain 1 electron. You get 8, minus 1 charge. This is fluorine, chlorine, bromine, iodine, acetylene. All right, so those are nice and easy because they're consistent. The problem with group 4 is right in the middle. It's halfway between 0 and 8. So it's kind of like it's just as easy for it to either lose 4 electrons or gain 4 electrons. And it turns out with some of them, either one can happen. They can either gain or lose 4 electrons. And then there's actually cases where they'll do different numbers. But for today, we're going to stick with that. So we'll say group 4, you can make this separate somewhere. Group 4A, carbon group. What's that? Carbon, silicon, germanium, whatever. Usually, or we'll say can be plus 4 or minus 4. And in fact, some of them can be plus 2 also. They're kind of funny. But we'll just leave it at that. And then there's one more group I skipped, right? Mm-hmm. And what's that group?
Group 8.
Group 8. And what's the charge of these ones? 0. Because they have a full outer shell. They can't gain electrons, they can't lose electrons. So 0 charge / do not ionize. And so to some degree, these don't matter because you're not going to see these in a compound. I'm not going to say, here's a compound that has xenon in it, tell me what xenon's charge is, because it's not going to be in a compound, because it doesn't react. It doesn't ionize, doesn't do anything. Same for helium, argon. Occasionally the lower number ones, actually xenon occasionally is in the compound, but very seldom. All right, so those are the rules. So that's pretty much it for today. I'm just going to give you a worksheet, and I'm going to say, I'm going to give you an element, rubidium. I'm going to say, what's the charge? You're going to look, rubidium's group 1, must have plus 1 charge, so on and so forth. Questions? All right. That's it. Yeah, done. It's New Year's, Once we get past Christmas, start taking it easy.
What's our midterm?
What?
Oh, can you shut this off, please, Michael?
Yeah.
Thank you.
What's our midterm?
We don't take a midterm in here.
Oh, we don't?
No, unless, last minute somebody changes their mind at the board office.